So if there are people trickling in from the waiting room, but we're going to go ahead and start. And all they're going to miss is my introduction, which is okay. Hopefully they'll all be in time for the meat of the webinar. So welcome everyone. Thank you for joining our webinar on conservation and proforestation options for New Jersey forests. I'm Eileen Murphy. I am a co-chair for the New Jersey Forest Task Force and Vice President of Government Relations at New Jersey Audubon. And with me today are my co-chairs, Anjali Ramos, who's Executive Director of the Sierra Club, and Andy Bennett, who is representing the New Jersey Forest Association. There is another co-chair, Tom Gilbert from New Jersey Conservation Foundation. He's unable to join us in person today, but he joins us in spirit. And of course, Tom is instrumental in the scheduling and the interpretation of these webinars. He just couldn't join us today. So that's enough from me. I am going to turn this over to Andy Bennett, to Anjali, who's going to introduce our panelists. Anjali?
Thank you, Eileen. Good morning, everybody. Thank you for joining us. We're very excited for this webinar, and I'm going to try to quickly introduce these fellows here, even though it's going to be difficult because they're quite amazing. So there's a lot to say. So I'm going to start with William Muma, or Bill Muma. He's a professor emeritus at Tufts University and distinguished visiting scientist at Woodwell Climate Research Center. He holds a PhD from MIT and previously taught chemistry and was director of environmental studies at Williams College. He's a physical chemist who helped develop the first ozone layer protection legislation while working for the US Senate, and has been a lead author of 5 intergovernmental panel on climate change, or otherwise known as IPCC, reports, including the 2007 report that shared the Nobel Peace Prize. He's currently working internationally and nationally to identify and implement natural climate solutions that accumulate additional atmospheric carbon out of the atmosphere in forests, wetlands, and soils. So thank you, Bill, for joining us. We're very proud to have you. Next, Ed Faison, PhD, senior ecologist, Highstead Foundation. Ed's work focuses on long-term forest change, deer-forest interactions, the ecology of wildlands, and natural climate solutions. Ed also advises conservation groups, educators, and land trusts about stewardship and forest monitoring. He holds a master's degree from the University of Vermont and Harvard, forest science, and a PhD from the University of Massachusetts, from the Department of Environmental Conservation. So thank you, Ed, for being with us. Next, Tony D'Amato, professor of silviculture and applied forest ecology and director of the forestry program at the University of Vermont. He received his bachelor's degree in forest ecosystem science from the University of Maine, master's degree in forest science from Oregon State University, and PhD in forest resources from University of Massachusetts. He was a faculty member for 7 years at the University of Minnesota and Bullard Fellow at Harvard Universities. Harvard's forest prior to joining the University of Vermont in January 2015. His research focuses on long-term forest dynamics, disturbance effects on ecosystem structure and function, and silvicultural strategies for conferring adaptation potential within context of global change, including introduced insects and diseases. So thank you so much, Tony, for being here. And last but not least, William Keaton, professor of forest ecology and forestry at the University of Vermont, Rubenstein School of Environmental and Natural Resources. At UVM, he directs the Carbon Dynamics Laboratory, and it's a fellow in the Gunn Institute for Environment. He also serves as chair of the International Union of Forest Research Organizations Working Group on Old Growth Forests and Reserves. His research focuses on forest disturbance dynamics, riparian ecology, forest carbon, old growth forests, ecological silviculture, and sustainable forest management in the US, Northeast, and Pacific Northwest, but also takes him frequently to Central and Eastern Europe, where he serves on the board for science for the Carpathians and is currently a Fulbright scholar. He has ongoing research also in the Chilean Patagonia and Bhutan related to wildfires and forest stream interactions. His new co-edited book is entitled Ecology and Recovery of Eastern Old-Growth Forests, and he holds a bachelor's from Cornell University, a master's in conservation biology and policy from Yale University, and a PhD in forest ecology from the University of Washington. So thank you so much, all of you, for being here with us. As you heard, I needed to read these bios because they're very impressive, and we're excited to hear you all speak. So thank you, and please go ahead.
All right. Well, just to add my voice to Eileen's and Angelique's, thanks guys for being here. We know you get all kinds of requests, I'm sure, to make presentations, and we are very humbled and grateful that you would just, take a few minutes to talk about the forests in New Jersey here. So, so just a quick recap of how this is going to go. Each speaker is going to get 15 minutes to make their presentation. At 13 minutes, I'm going to just not interrupt, but just quickly let you know you got 2 minutes left, just to kind of give you your 2-minute warning, just like the NFL. So there you go. 2-minute warning. And then once everybody's wrapped up, we're going to give you again another couple of minutes to make any clarifying comments, ask questions, et cetera, et cetera. And then we'll transition to Angelique, who's going to do our Q&A. So it's going to go Bill Muma, Ed, Bill Keaton, and then Tony. That's going to be our order. Okay, so Bill, we'll get you teed up here, get your screen shared, and we'll get things started. I'm going to have a clock here on my phone, so I'll try to keep us on schedule.
You're muted, Bill.
That's the standard opening statement in a Zoom call these days, isn't it? Sorry about that. Thank you very much for inviting me to participate in this. And I wanted to say what an honor it is to be on this with my colleague Ed Faison and Bill Keaton and Tony D'Amato, whose work I greatly admire. So when it was presented to me that this was a debate about should we have proforestation or not, and since Ed and I are the guilty parties for introducing the term into discussion, I thought I'd title this "To Proforest or Not to Proforest, That is the Question." I just, what I've tried to do also is, as much as possible, to use photos and things from New Jersey, although I have other data from other places. So what is proforestation? Forestation means to grow a forest. Reforestation is to replace a forest that has been removed by either harvest or natural disasters. And afforestation is to plant a new forest where none is growing before. Proforestation is the practice of protecting existing forests from harvest to foster continuous growth, carbon accumulation, and structural complexity. So I will make the argument about how this natural climate solution can increase the removal of atmospheric carbon dioxide and accumulate the carbon. So let me just be clear, and I think we ought to all think about this. What is our position and what is our interest? My position is to promote proforestation as part of the climate solution. My interest is to halt the increase in global heating as rapidly as possible. My method is to grow more trees to become large trees that accumulate more carbon in forests and reduce the emissions of heat-trapping carbon dioxide in the atmosphere. And my justification is that that this will all reduce the risk of major warming-induced amplifying feedbacks, such as methane released from thawing permafrost in the Arctic. These runaway, not only potentially, but are actually happening, could make it impossible eventually to stop global warming unless we halt it sooner. As you all know, climate change is already happening and is having its toll. These are just some examples from 2018, the storm surge on the upper right, but down just below it, the incredible flooding in Germany in 2021. So these are all things that have been happening because of a warmer world. Governments said that they wanted to keep temperatures from rising more than 1.5 degrees Celsius, which is 2.7 degrees Fahrenheit. And the language from the report of the Intergovernmental Panel on Climate Change says that basically to keep temperatures from rising, global net anthropogenic carbon dioxide emissions must decline by about 45% from 2005 levels by 2030, reaching net zero around 2050. So we hear a lot about net zero, but everybody fails to read the next sentence, which says, then we must be carbon negative indefinitely beyond 2050. And so we must simultaneously reduce CO2 emissions from all our energy and land change and increase its removal from the atmosphere. And because of these feedbacks I mentioned, there's just a 2 in 3 probability that meeting net zero can be done with this particular scenario. And this is just from the latest IPCC report. And these are the various scenarios of how our emissions will go between 2015 and 2100. And the only one that really meets the goals is the blue one at the bottom, which, as you see, goes to zero, meaning that nature is taking out more than we're putting in, and then it continues negatively after that. So let me just give you the global sense of how the carbon cycle is working. We have been emitting about, this is for the decade 2011 through 2020, about 35 billion tons of carbon dioxide and about 4 billion from land use change. That is deforestation, it's forest harvesting, it's burning bioenergy. All of those are supposedly in that number. And yet, remarkably, so that's 39 billion tons. Remarkably, the increase in the atmosphere is only 19. And the reason for that, of course, is nature is helping us out. We have no technologies that have this kind of a remarkable effect. And about 11 billion are going to plants on land, and about 10 billion are going into the ocean. And in the plants on land, the largest part of that is forests. So increasing carbon accumulation by forests to meet climate goals. And here's some just remarkable recent research. The largest 1% of trees in mature and older forests comprise 50% of forest biomass worldwide. That was a paper by Lutz et al. In 2018. Altering forest management to let more trees grow would allow global forests to accumulate twice as much carbon. That's a paper from a group in Austria in 2018. And in a paper that I was a co-author on, but all the data analysis was actually done by Mill Drexler and others, Beverly Law and Richard Birdsey. The largest diameter 3% of trees in Oregon's 6 national forests hold 43% of the carbon. So big trees matter. I found this picture in Burns State Forest in New Jersey of a really big tree. And so that tree is holding a lot of carbon. And just for comparison, my friend and colleague Bob Leverett put this together. Tony knows Bob very well. A single large red oak that's maybe 125, 150 years old, 100 feet tall, 54 inches in diameter, holds 8 tons of carbon. If you had trees half that height, it would take 35 of those to have the same amount of carbon. And those would be around 29 or 30 years old. If you had street trees that are 40 feet tall, you'd need 151 of those. And if you had trees that were only 25 feet tall, it'd be about 465. So there's just a huge difference between big trees and little trees. Big trees hold the most carbon, and those are the ones that need to be protected. This is a picture of a big tree. It's in Western Massachusetts in Mohawks Trail State Forest. That's me there enjoying its accumulation of carbon. So planting trees is good, but letting them grow is better. And proforestation produces more large trees, storing more carbon than just planting new ones, or sustainable forest management can by 2100. And proforestation management is among the least costly options for removing and storing additional carbon dioxide out of the atmosphere, because half the carbon in a tree half of the weight of the tree, the wood in the tree, is carbon. And so creating some kind of strategic climate and biodiversity reserves is a proposal I'm going to develop a little bit later. So atmospheric carbon removal. This got a lot of attention. Climeworks in Iceland has built this amazing technology here that's run by geothermal energy and sucking up air and removing currently 2,000 tons of carbon dioxide per year. Natural solutions, however, are removing 11 billion tons of carbon dioxide per year. That is the plants on land. And this is just a little figure I found online describing proforestation is going from a degraded forest system to a secondary forest recovery to eventually achieving qualities that are more like those of a primary forest. This is an example from some pine stands in the Northeast U.S. There's been a lot of discussion about sustainable forestry. And so if you had a 50-year-old stand of pine, in this particular case, it'd hold about 22 tons per acre in the trees. If it's harvested, it goes to 0, and then by 50 years later, it grows up again, and then it's harvested, and it grows up again 50 years later. And in that situation, it's never more than 22 tons, and it's as little as 0, with the difference being in the atmosphere. And so the average stored carbon dioxide is somewhere between 0 and 22. On the other hand, if those trees had been allowed to grow for the next 50 years, there'd be 47 tons in those trees. And then if they were allowed to grow for the next 50 years, there'd be 76 tons. And so the average stored would be much, much higher. And that's the argument for proforestation. And in some work that was done by Professor Beverly Law at Oregon State, looking at carbon accumulation in Oregon forest by 2100, comparing afforestation and reforestation, both involving planting trees, and proforestation. So out there are a lot of these clear cuts. And so the question was, what would happen if you replanted all those? And so here was the outcome. The reduced forest harvest rather is a proforestation strategy, or partially proforestation strategy, reducing the harvest on federal lands by half and increasing the harvest intervals to 80 years on private lanes accumulates 3 times as much as reforesting, planting all these clear cuts, and planting trees every place you could in Oregon that didn't already have buildings or agriculture or forests on them. And so where is the carbon from harvested forests? And in 2016, the U.S. Forest Service published this report that found that that if you look at where emissions come from, and there's insects and fire and wind fall and harvest and conversion, and harvest is 85% of the emissions. And in a different study by Tara Hutteberg at the University of Idaho, looking at what's happened to all of the carbon that's been harvested since 1900 to 2015 in the 3 western states. 19% was in long-lived wood products, 16% was in landfills, and 65% was in the atmosphere as carbon dioxide. So over 115 years, there's twice as much in the atmosphere as carbon dioxide than there is that's out of the atmosphere. So what are the forests like in New Jersey? And according to the U.S. Forest Service, the mixed hardwoods in the north and the pines in the south, that 15% of the forest area is over 100 years, 6% is over 120 years, 0.8% is more than 140 years. And I just learned that about 4.5% is less than 20 years. So there's 5 times as much in early succession as there is in the oldest class. And proforestation means protecting these larger, older trees and allowing more mid-sized trees to become larger, older trees. Forests are for people's enjoyment and mental health. These are 2 pictures from I found on the web of some New Jersey forests. And these are wonderful examples of people enjoying forests, and there's a lot of research showing that spending time in forests does improve our mental health, and it actually causes changes in our brain chemistry. My proposal: establish two types of forests. One would be strategic climate and biodiversity reserves. This is Ski Houghton, and this is Wayne Walker from Woodwell Climate. They're both very prominent forest carbon research people, standing next to one of these really large trees that's been allowed to grow. And then we create industrial production forests. This is a photo I took that's about 10 miles from this picture right here. And those would be, we would not try to do all the same thing on the same lands. The U.S. Forest Service classifies 70% of our forests as timberlands, meaning they should all be available for harvest. And this statement, nature needs half, was put forth by E.O. Wilson, who's one of the co-founders of biodiversity science. Protecting and interconnecting at least half of the planet's land and water is necessary to sustain the health, function, and diversity of life. Ed sadly passed away the day after Christmas last year. But the IPCC report that came out in February, interestingly enough, just 2 months after he passed away, had this statement: safeguarding biodiversity and ecosystems is fundamental to climate resilient development in light of the threats climate change poses to them and their roles in adaptation and mitigation. IPCC makes that statement with very high confidence. It goes on. Recent analysis drawing on a range of lines of evidence suggests that maintaining the resilience of biodiversity and ecosystem services at a global scale depends on effective and equitable conservation of approximately 30 to 50% of Earth's land, freshwater, and ocean areas, including currently near natural ecosystems.
So down to 2 minutes. Sorry, 2 minutes.
I am down to 2 minutes. Building, and then it goes on, building the resilience of biodiversity and supporting ecosystem integrity can maintain benefits for people, including livelihoods, human health and well-being, and the provision of food, fiber, and water, as well as contributing to disaster risk reduction and climate change adaptation and mitigation. So, what is in the best interest of society? Gifford Pinchot, back shortly after 1900, made this famous statement: how do we meet the greatest good for the greatest number for the longest time? Well, I would argue that halting climate change seems like a strong candidate for the greatest good for the most people for the longest time. This is also a picture from a New Jersey forest. So to pro-forest or not to pro-forest? If your interest is to halt climate change and eventually return to a safer climate system without runaway feedback loops, pro-forest more. If your interest is to produce more forest products, pro-forest less. How much to allocate to each option is a political decision for each of you to decide. Thank you.
Awesome. Thanks, Bill. That was awesome. Thank you so much. All right, we're going to go to Ed. Ed, let's see if we can get the screen share working.
How's that look?
Looks good. Just a side remark. Bill Mumas set the bar high. He went 15 minutes and 45 seconds. Spot on, Bill. Good job.
All right. Well, thanks very much. And it's good to be here with my fellow panelists and all of you from New Jersey. I'm going to try to jump right in here to try to keep this to 15 minutes, as Andy said. So Bill defined proforestation already, and I'm just going to include it again here. I'll mostly be using the term wildlands in this talk, which is largely synonymous with proforestation. And wildlands are defined here as forests that are specifically set aside to be protected from timber harvesting and most other forms of management to allow natural processes to prevail. And here are some of the more prominent examples of this type of management. So I'm going to start by showing a few results from a study that I'm currently working on in the Northeast, comparing carbon storage, growth rates, and the structure of wildland forests versus surrounding forests that are not protected from management. And this work builds on many great studies that Bill Keaton's lab in particular has done here in the Northeast on carbon and forest structure. And our study area included all of the wildlands identified in blue on this map of New England, which was recently developed by collaborators at the Harvard Forest, as well as the Adirondack and Catskill Forest Preserves in New York. We didn't include New Jersey, but much of this information should be transferable to New Jersey. And the idea here was to compare USDA Forest Service monitoring plots that are exposed to very similar growing conditions, but differ primarily by their protection from or exposure to management. So starting with above ground carbon, which is the total amount of carbon stored in both live and dead trees. And carbon is plotted here by state with Connecticut, Massachusetts, and Rhode Island combined on the left because of low sample size, and all refers to the combined plots from all the states, and that's on the far right. The dark green points are wildlands, light green points are non-wildlands. And I should note that non-wildlands are not necessarily recently managed forests. In fact, over 90% of them had no sign of recent harvesting. They're just not protected from harvesting. The asterisks simply mean whether the difference in the comparison is statistically significant, with more asterisks being more significant. And you can see that carbon storage was particularly higher in Maine and New York wildlands and overall compared to surrounding non-wildland forests, with the differences ranging from about 20 to 33%. And this likely reflects both the time protected as wildlands, which are oldest in the New York preserves, and the legacy of harvesting in the surrounding forest, which is highest in Maine. In southern New England, where time since protection of wildlands was the youngest, and the level of harvesting in the surrounding forest relatively low, we don't see much of a difference. Now, if we just look at the subset of recently harvested plots across the region, we see that carbon storage is now almost twice as high in the wildland forests. Okay, turning now to total forest growth rate, and BAI on the y-axis stands for basal area increment, which is the summed annual growth increment of all the trees in the plot. And it's a good proxy for carbon sequestration. And if to use a banking analogy, think of carbon sequestration as the size of a paycheck being deposited each year into a bank account, whereas storage, which I discussed on the last slide, is the total balance in that bank account. So total forest growth rate was 20% higher in Maine wildlands, and that was a significant result. And the overall trend, though not quite significant, was greater in wildlands. And if we look at basal area increment, just in recently harvested areas, again, we also see a trend toward higher total forest growth in wildlands than in the surrounding forest, although, again, the result was not quite significant. Turning now to forest structural characteristics, which contribute to the complexity of the forest, which in turn determines the number of habitat niches and resources that are available, and is directly related to the biodiversity these forests can support. So forest structural complexity is also related to the resilience of a forest and its ability to adapt to future climate disturbances. So one important structural feature is the number of large trees in the forest, which Bill just mentioned as being very important to carbon storage. And you can see that New York and the region as a whole had over double the number of large trees in wildlands compared to the surrounding forest. Oops. And the next graph shows tree size class diversity among 4 size classes of trees, which are listed to the right of the graph. And this index reflects how evenly distributed the different size classes of trees are in the forest, which in turn is indicative of the vertical layering of the forest. And again, you can see that size class diversity was notably higher in the wildlands of New Hampshire and New York and across the region. Next is large standing dead trees, which contribute to structural complexity by creating canopy gaps and providing important food and nesting habitat for many birds and mammals, as well as habitat for invertebrates and fungi. And large dead stems were a pretty remarkable 400 to almost 700% higher in Maine and New York wildlands on average, and over 250% greater in wildlands across the region. And this likely reveals the legacy of dead tree removal from traditionally harvested forests and the development of these structural features in areas with the longest protection. And what I find interesting about these results is that both categories of forest averaged well under 100 years of age. So these divergences in carbon and structure can start to happen quite early in the aging process with protection from management. And lastly, tree species richness, or number of tree species per plot, which is a measure of diversity. And interestingly, there was no difference in tree species richness between the categories in any of the states or across the region, which suggests neither a great benefit nor detriment to tree diversity as a result of proforestation, at least at this stage of development. This actually contrasts with other regions of the eastern US, where tree richness was found to be significantly higher in national parks in the mid-Atlantic and southern Appalachian regions compared to surrounding forests. But interestingly, an important tree species that is shade intolerant and in steep decline in the Northeast, paper birch, generally fared better in wildland forests than in surrounding unprotected forests, suggesting that a lack of management is actually more beneficial to this early successional tree species than a legacy of management in the surrounding forest, which includes the harvesting of this tree. Okay, so one of the common responses that comes up when discussing proforestation or wildlands is what about the need to manage for young forest species that are in decline? And while it's true that on average, a wildland forest will not provide the same amount of young forest habitat as a more actively managed forest, and therefore will not provide the same abundance of most of the species pictured here, it's important to keep some things in mind. And first is that the amount of young forest habitat from natural disturbances and openings in large wildland preserves like the Adirondacks at 3% is actually quite similar, and perhaps even on the high end of estimates of pre-colonial young forest percentages in northern hardwood forests of the Northeast. And second point is that many species that are reported to require young forest habitat are actually a lot more flexible in their habitat requirements. The towhee on the left and the two cuckoos next to it, for example, can use a full range of forest age classes, and in some cases prefer older, mature forests with thick shrub layers. I was actually in Virginia last month hiking in some federal wilderness areas, forests, and indigo buntings were one of the most common birds I encountered, particularly in one of the oldest forests with its relatively more open structure. The New England cottontail, which of course is less relevant here in New Jersey, is frequently a target species for young forest management. But interestingly, recent research suggests the species may actually fare better in mature forest habitats, particularly when it co-occurs with the introduced eastern cottontail. And the authors of this paper actually recommended against young forest habitat management for this species. And the third point to consider is that many of the true shrubland species pictured here were rare or absent in most of the Northeast prior to widespread land use changes. And as forests were cleared for agriculture in the 1700s and 1800s and subsequently abandoned in the late 19th century, it resulted in this unprecedented spike of young forest habitat and a huge increase in young forest species, many of which expanded their ranges into the Northeast from their pre-colonial ranges to the west and south. And because young forest habitat is inherently transitional in the Northeast, it's no surprise that this habitat structure has declined along with the species that use them. Still, with ongoing disturbances from power line cuts, increased outbreaks from invasive forest insects, extensive residential edge habitats, and timber harvests for wood, there are enough disturbances on the landscape that will very likely maintain these species at levels higher than they ever were prior to land clearance. And one mitigation management strategy that I would like to draw attention to that complements proforestation and has great potential to benefit climate and shrubland species is allowing currently non-forested areas, sort of grassy areas, to naturally grow back into young shrubby forests by not mowing them. And naturally reforesting areas would store a great deal more carbon than the current grassy vegetation in these locations, and provide some habitat for shrubland species without cutting mature trees that results in a steep carbon loss. Another point that I often hear in response to proforestation is that mature forests lack resilience without management and won't be able to regenerate following disturbances because deer, too much shade, or both eliminate seedlings in the understory. And the quote I put in here is pretty typical. These pictures from 2003 are from Uttertown Forest in New Jersey, which many of you may be familiar with, where deer densities are quite high. And the understory is pretty sparse from browsing and likely a deeply shaded canopy. But look what happens over time by 2018 when the oak and hemlock overstory starts to die from insects and wind. The site is transformed as light from the canopy gap stimulates tree regeneration and overwhelms the ability of the deer to control it. So in other words, northeastern forests have a pretty remarkable natural resilience in the midst of a full range of disturbances, whether deer browsing, windstorms, insect outbreaks, fire, that I think we as stewards too often underestimate. And I just want to give a nod here to Tony's research on the recovery and response of New England forests. In response to major windstorms like tornadoes and hurricanes, which has helped us better understand the recovery and inherent resilience of many of these systems. Okay, so determining how much land is set aside for proforestation will obviously come down to values and priorities of the people here in New Jersey. And as Bill said, it's a political decision. Here are two very different examples from neighboring states of wildland protection and management on state land. In New York, which has a long history of legally protecting forever wildland, approximately 75% of the state's forest land is set aside as wildland reserve. On the other side of the spectrum is my state of Connecticut, which generally puts a high priority on forest management and a lower priority on wildlands and manages only 5% of its state lands as reserves. New Jersey is somewhere in between. And one good thing to remember is that even in the New York scenario, there is still an abundant percentage of land across the state's public and private forests in which to conduct experimental management, wood harvesting, and a diversity of other activities. So I'm going to stop there and thank you very much.
Awesome, Ed. 13 minutes and 30 seconds. You had a minute and a half to go if you want. Awesome. Thank you. All right. Next, Bill Keaton.
I think it's Tony, isn't it, Andy?
It doesn't matter.
Okay.
If one of you guys want to go, Bill, if
I'm
you're
happy
ready.
to go as long as Tony's okay with that.
Tony,
Yeah,
you good?
I set it up that way, Bill. I think I was going to follow you. So,
Oh, okay, great. All righty, just boot it up here. Okay, let's see here. Sorry, 1 minute. Okay, well, thanks everyone for coming this morning, and thanks again for the invitation to be part of this panel. Indeed, it's an honor for me also to be speaking with the other panelists today. So I wanted to take a very expansive view with my talk this morning, which is why I've called it Holistic Forest Conservation and Management. And I'd like to think a little bit about the proforestation proposal, or what we might call passive management, or a reserve-based approach. And I'd like to put that within a larger context of conservation approaches and sustainable forest management. So I have a couple of points today, a few of which maybe open up a little bit of a debate relative to what the other panelists have presented so far. So my points are, first, that I'd like to make an argument that we need to be very careful about not returning to what I will call a false dichotomy of the past. I'll explain that a little bit more later. I want to emphasize that contemporary sustainable forest management integrates multiple complementary approaches, including reserves. And if we apply the lens of natural climate solutions, which is also a field that I work very actively in, we need to think about the full portfolio of carbon forestry options, of which reserves and passive management and old growth forests are just one element of that portfolio. And along with the portfolio idea, I want to explore the idea of trade-offs between approaches that we might consider, and how we spread risk, how we spread uncertainty, and how we adapt to an uncertain future. And then finally, I'll close with the idea that active and passive management, including what we're calling today proforestation, are really not mutually exclusive ideas, but we have to take an adaptive approach no matter what we do. Okay, so let's start with the first point about not returning to the false dichotomies of the past. What I mean by this is that, of course, forest management in the United States has a very, very long and in some cases fraught history going way back to the 1890s. And of course, as a discipline, it extends much further back, in Europe for multiple centuries before that. And we've come a long, long way since the early, Muir versus Pinchot debates of the early 20th century. But then if we think about maybe the 1980s, especially in the early 90s, as really this formative period of change in the United States, I think it's highly informative. So the dichotomy, what do I mean by that? Well, for many, many decades in the United States, despite the multiple use mandate on national forests since the late 60s and mid 70s, the hard reality was we were overcutting the national forest system, particularly in the 1980s. And we produced a very, very heavily, intensively managed landscape that was in contrast to the very strictly preserved and protected congressionally designated wilderness areas and national parks. And it produced this dichotomy between basically passively managed reserves and very intensively managed forests outside of those. And it produced tremendous problems with endangered species, watersheds, compromised recreation, and reduced opportunities for a whole range of uses and values. And it resulted ultimately in an injunction on timber harvest in the Pacific Northwest and forced the science and the profession of forestry to really re-examine the way we do business. So that we think about the old growth wars of the 80s and early 90s, and the understanding that developed that old growth systems were important for a very wide range of species, not just northern spotted owl, but many, many others. And so we had to search for new approaches. And what did we learn from this? What did we learn from that dichotomy that produced that situation? Well, new ideas, new paradigms emerged around sustainable forest management. And we understood that we actually needed a much broader toolkit, a much greater range of options and ways to protect and manage forests. And one example of a new paradigm or a general approach that emerged that I think is still highly relevant today, although it just doesn't get as much airtime, is this idea of ecosystem management that really laid the groundwork for what is now the Northwest Forest Plan, covering Western Washington, Oregon, and Northern California. And it relied on a number of things that are relevant to our discussion today. First of all, it was science-based. But rather than sort of this two-zone system that we're debating this morning, it relied on a very complex, sophisticated land allocation system, including reserves, both those that had already been designated, as well as a new system of late successional or old growth reserves, but also many other types of land management categories that would have different intensities of forest management and protection applied to them. Some of these categories emphasize aquatic species and watersheds, others emphasize recreational uses, others emphasize various degrees of timber harvest or fire restoration. So a very complex system. Reserves were the foundation, but also outside of the reserves, this paradigm brought in new concepts of sustainable forestry that we could refer to as ecological silviculture or variable retention harvesting or any number of different terms. I'll talk more about that later. I want to emphasize, though, that the foundation for this approach was the idea of a comprehensive reserve system. So I think this is something that all of us this morning agree on, that we need a well-distributed, fully representative of ecosystem diversity and comprehensive reserve system. So that was the foundation around which all of those other land allocations or zonings were built. But even here in the Pacific Northwest, there was the understanding that many times inside reserves, some degree of management might be warranted. So for example, in this case, the reserves really just represented highly fragmented patches of old growth that remained. And there was a need for restoration forestry in and around those patches to reestablish larger, more contiguous areas of old growth structure. That same concept now is used all over the world in different ways in terms of restoration and invasive species control and fire risk reduction and all kinds of activities that are often needed inside of reserves. So active management in stands less than 80 years of age. In this case, to actually accelerate the development of old forests or to restore them more quickly than they might otherwise have developed. So we learned a lot from the Northwest Forest Plan and from the timber wars of the 80s. And we've come so far as a profession and as a science since then. And here's where I really want to emphasize that forestry and forest science are not static endeavors. Like any science-based profession, these are constantly evolving, constantly developing. And we have many, many new models now that are actively used all over the world and here in the Northeast as well, like this one. So this is an idea that I proposed actually a number of years ago in an essay in the George Wright Forum, where I tried to sort of break out what we had learned from that false dichotomy of the past and the new understanding that holistic forest conservation and management is really a spectrum of possibilities. It's not just two simple categories, it's a continuum of options. And we could break down this continuum any number of ways, but we could think about it in terms of the IUCN protected areas categories and how those represent different intensities of protection and different types of activities that are accommodated within them, as well as things we do on the unprotected landscape, with certification and carbon projects and all kinds of different things. And then we think about this sort of the portion of the landscape that is managed in some way as a complement to the reserves. Again, as a complementary strategy, a mutually reinforcing strategy that sustains the ecosystem, that sustains the landscape. Some people have called that matrix management, but I would say the more contemporary terms here are things like ecological silviculture and restoration forestry and adaptive forest management. This is also where we're thinking about carbon forestry options, and Europeans might call this multifunctional forestry. So all of these sustainability approaches that we use on the active landscape as a complement to the protected areas. But again, it's a continuum, it's a range, a spectrum, not a dichotomy. And if we think about proforestation, or I'm going to call it passive management, there's a role for this. Absolutely. Everyone on this call agrees for that. In some parts of the world, we call that upgrading the protection status. So if we already have protection areas, but they're poorly protected, maybe we can upgrade the level of protection. The debate, as Dr. Muma said, and as Ed said as well, is ultimately a political one in terms of how much of the landscape we allocate to these two approaches. Do we want to adopt more of the passive management approach, or do we want to maybe rely more on ecological silviculture? Again, that's a false choice. We can do some of both, but the fundamental lesson is that there is no one-size-fits-all approach to any kind of forestry. And that's because there is so much ecological variation on the landscape, and we have so many different scenarios and contexts that we find ourselves in, that even if we all agree on reserves as the foundation and the need for maybe more wildland reserves, more core reserves, more strictly protected IUCN category 1, 2, and 3 reserves. This is the wildlands and woodlands vision that several of us on this call were co-authors on. We all agree on the need to increase the representation of wildlands and core reserves. This is for New England. But as I said, there are always scenarios in which active management, sustainable forestry approaches are going to be needed outside of those wildland reserves in the managed landscape. The wildlands and woodlands vision, for those of you who are not familiar with it, imagines us achieving 70% protection of forests in New England by the year 2070. 63% of that would be in managed woodlands, 7% would be in wildlands. This is what we think is the achievable goal. But in these woodlands, there are so many reasons to consider continued active management. First and foremost, natural disturbance regimes are changing. The frequency of extreme events like windstorms, ice storms, even fire, insect outbreaks is increasing. This presents real challenges if we try to put, all of our money, we try to bank entirely on a wildland approach. We know we have the legacy of land use history in terms of altered successional pathways in forests that are not developing the way they have in the past. Think about beech bark disease and beech thickets as understories that are fundamentally altering the way our forests develop, meaning we can't necessarily count on them to develop towards a condition that they might have in the past, 2 centuries ago, 3 centuries ago. Invasive species and fire restoration, it's a continued need. The mesification of oak forests, which is certainly relevant to New Jersey and the central Appalachian states as well. The idea that we've changed the microclimate of oak forest understories because of fire suppression, overbrowsing by deer, and this has resulted in a whole-scale successional change in these oak forests that's sending these forest systems off in a different direction. That's a complicated topic that perhaps we can discuss later. And many other reasons why some degree of active forest management will be needed probably on the majority of the landscape. So again, we need to keep both options available. And I just wanted to again emphasize this idea that ecological silviculture and sustainable forestry practices have come so far since the 80s and 90s, and we now have a much larger toolkit at our disposal, many of which do a very good job of balancing multiple objectives like habitat for biodiversity, including large trees and other elements of late successional and old growth forest structure, as well as ecosystem services like carbon storage and flood resilience and all the other things that we care about. So look at Audubon silviculture with birds in mind as an example. This is a paper I was part of just a couple of years ago in which we looked at a full spectrum of forestry for the birds treatments and how those balance and trade off different objectives that we care about. Again, the idea that there is no one size fits all solution. Anything that we do has trade-offs in terms of future risk, vulnerability to disturbance, the types of habitats we produce, the carbon storage benefits, et cetera, et cetera.
2 minutes.
2 minutes. Okay, I really need to cruise through the last part. Okay, so related to this idea that there's we need a toolkit and there are trade-offs. If we think about just carbon forestry and natural climate solutions, we need to remember that there's a portfolio of carbon forestry options out there. And this is important because the portfolio approach spreads risk. We understand that anything we do, including passively managed reserves, carries risk. It carries vulnerability. For passively managed reserves, it might be vulnerability to disturbances and altered disturbance regimes or invasive species. It might be these altered successional pathways I'm talking about. We need to spread that risk. We can't put all our eggs in one basket. So the portfolio maximizes benefits while minimizing risks. Let's quickly review what the portfolio of carbon forestry options is or includes. So certainly passive management, what we're calling proforestation, is an option, and it's an important one worldwide. So we often refer to that with the term avoided deforestation, conservation of high conservation value forests like old growth forests, unmanaged reserves, wilderness areas, or smaller inclusions in actively managed forests. It's very important. But even this, I want to point out is the subject of debate. And we always have to keep in mind that the science around these things is constantly evolving and changing. So even this question of carbon storage in old forests is subject to debate. We had an initial flurry of studies, some of which were my own, that generated a lot of excitement around that idea. Later, those studies were questioned and debated and countermanded. And so even this question of like carbon storage value of old forest preserves is uncertain. And so we need to understand that uncertainty and that risk.
30 seconds, Bill.
Okay.
Wrap it up.
Almost done, so I'll just skip this part. So we have other elements of the carbon forestry portfolio, right? Reforestation, afforestation. This carries risks too. We understand that there are trade-offs with planting trees, and actually that might be a long-term climate solution, but maybe less beneficial in the near time. And let's not forget that there's a full range of active carbon forestry approaches that many other communities are also extremely excited about. The idea of retention forestry and extended rotations, practices that improve tree growth, even practices like this one that I've experimented with called structural complexity enhancement, which is a way of restoring old forest structure. And then other things like mass timber and durable wood products, and of course, fire restoration and fuels treatment. So these are all of the elements in the portfolio that we need to think about. Again, it's not a dichotomy. There's a wide range of options at our disposal. Okay, so then to wrap it up, take-home messages today. Holistic forest conservation requires a portfolio of complementary approaches. These have to maximize the full range of benefits to nature and society while minimizing risk. Active and passive management are complementary, not mutually exclusive, and there's no one-size-fits-all approach, particularly in a rapidly changing world. We have to take an adaptive approach. Sorry I had to skip through some of that, but thanks again for having me today.
It was great. Thanks, Bill. All right, Tony, you're up. And then remember, you guys will have a couple minutes on the back end here to kind of, if you feel like you forgot something, you can cover it in your 2 minutes there.
All right, you seeing that?
Yep.
All right. So everybody, as others mentioned, it's great to be part of this panel, and I appreciate what both Bills and Ed had to say. And my goal here is really, as a last person presenting, I assume there might be some overlap and hopefully some complementarity between the different messages. But just from my perspective, forest scientist, works in forestry, both passive management as well as active management, and really the goal and our community is to be objective and really to look at these questions broadly. And so my hope for this presentation is really just to kind of touch upon, as we're grappling with what should happen on public lands in New Jersey and some of the discussions as what should happen in the region, is just to reflect on how it's been approached elsewhere. And Bill really nicely teed that up. And even though he's an office above me, we just found out the other day what we were even doing this. So we did not coordinate our presentation. So, but thankfully there's some synergy with his as well as with Bill Mumaz. So as has been mentioned, and certainly Bill Mumaz's final, there we go, slide highlighted, we have a lot of values that we get from forests, and certainly the word carbon's been used more than any other value today. But when we look at forests, and many of these photos are from the Northeast, I apologize. Closest to New Jersey is some pine barrens from Long Island that we work in. But there really are a lot of different values we get, whether they're cultural, ecological, aesthetic, recreational. And when we look at wildlife species, there are different species that rely on different types of forests and different types of features. And this ecosystem services like water filtration and carbon storage, many different things, many different places, and really many different forest conditions that provide those benefits. And so as Bill mentioned, Bill Keaton, two Bills here, really nicely in his presentation, there's been a long recognition, first and foremost, within the forest conservation and more broadly, wildlife conservation and communities, that there are multiple goals, multiple values for any given area of land. And our task as stewards of that land is really to objectively use science as well as, use personal opinion, social needs, economic needs, policy mandates to inform kind of the best practices to balance to the best of our ability these many, sometimes complementary, but sometimes conflicting goals and objectives for the amazing ecosystems we're talking about today. And so as was mentioned in Bill's presentation, and also certainly referred to as well in Ed's presentation, there have been some regional looks already at how do we conserve this amazing, we often consider kind of natural infrastructure of the Northeast, which are these forested landscapes. And one of the more popularized ones, and Bill summarized that already, for New England is what we call wildlands and woodlands. And the only reason I'm revisiting that is that it's not just called wildlands and wildlands or woodlands and woodlands. Really, when we think about forests and forest conservation, we really are acknowledging that in many cases, we can't satisfy every given value or objective in the same place. And so we often need to think about a mixed use across a large landscape that's informed by professionals and science in terms of how we make decisions in those areas. Similarly, zooming in into the state that Bill and I both live in, even the state of Vermont has put a lot of work into thinking through what are our conservation targets for the future in this wonderful plan called Vermont Conservation Design, informed by ecologists, wildlife biologists, forest scientists, land trusts, others. And within that, again, the key element is that we want to protect forest, but we want to protect young forest, old forest, and in some cases, creating these conditions both through passive as well as active management. And then finally, again, good complementarity with what Bill just talked about, zooming in on one of these public ownerships, the Green Mountain National Forest, the southern end of that. This map here is just to show you a diversity of colors, all of which within this public ownership correspond to a different management regime. So the pink there is wilderness. We can call it proforestation. We can call it unmanaged. Other colors represent recreational emphasis. Other colors represent diverse management, but that might include forest harvesting. The point being that when we're thinking about how land is managed in the landscape, we really are trying to balance these factors. And this really isn't Pinchot versus Muir. We've come a long way from those discussions and really thinking about multiple use from an ecological standpoint. So what I figured I would do for this presentation, given I was at the end, is just kind of go through what some of the common features are in other states in kind of the region just to your north of these plans that are looking at kind of regional conservation priorities and how do we conserve forest, this critical resource going forward. And so the first commonality across all of these plans is that the most important thing we can do if we care about forest for carbon, forest for wildlife, forest for water, forest for recreation, is that we need to keep forest. And what's been a bit challenging, I think, about this discussion around proforestation is it really doubles down the emphasis of all of our forest conservation energy on public lands. And in reality, the biggest impact of forest carbon is losing forest. The biggest impact of forest-dependent organisms is losing forest. And just like the rest of the Northeast, New Jersey, unfortunately, has been on the trend of losing forest every year, actually an area larger than the wildlife management area that motivated a lot of our discussions today. Each year, we're losing 4,000 acres of forest to non-forest use. This is not going to go back to forest. So it could be a housing development, a solar array. But these are places where I think those of us that care about forests, which I think are those of us that are all logged in and beyond, a lot of our energy, if we care about carbon, care about forest diversity, should be let's keep forest. And that's often how do we find ways to keep public forest land private forest land protected. The second thing, and Bill mentioned this again, there's often this false dichotomy painted that if you're a forester, if you're a wildlife biologist, you really are kind of coming out of the 1900s, schooling, and you don't think about the need for wildlands. But there's a long history and legacy. And ironically, both Bob Marshall and Aldo Leopold were trained as foresters. So some of the pioneers of wilderness conservation in New England, as well as broadly around the globe, came from foresters. And part of their recognition was that unmanaged areas are a key part of our landscape, both spiritually, ecologically, but those are mixed with other types of uses. And so many of these ideas, and this is an example from Maine, it's known as a triad concept. So we have unmanaged areas on the left, areas that are managed with some of the principles that Bill was talking about, as well as some areas that are managed with the principles that the other Bill was talking about, really are allocated across that landscape to balance some of these needs. And the point being is that, even when we're talking about planning for public lands, you can include wild areas, and that's a big part of what we should be doing, and that's been acknowledged for a long time. From the management side, in terms of active management, these are really critical benchmarks for us to evaluate how our areas that might actually have some management occurring, evolving over time in response to areas that aren't. So it's really an important part of our stewardship to make sure we are including an element of proforestation, wilderness as part of the broader portfolio of things we're doing. Another thing that's critical is that all of these other regional conservation plans recognize the importance of management. And to Bill's point, there's a lot about our current forests in terms of the simplicity, certainly the wildlands that Ed was pointing out and comparing to managed areas really illustrates that. In a lot of cases, there's quite a bit of disparity in our second growth forests in the region from the complex systems that were here historically and maintained by both natural processes, as well as importantly maintained by cultural practices like indigenous burning. And so using active management in these areas, not all of these areas, but portions of these areas can actually be a key tool to accelerate some of that complexity, as Bill mentioned, enhance some of the carbon potential in these places, and also just maintain the habitat values for a wide range of species, not just those dependent on interior forests, not just those dependent on open lands, really that mix. And so more broadly, as we think about impacts of stressors in the landscape, and so southern pine beetle can be a prime example for New Jersey, dense, pitch pine forests that haven't been thinned, haven't had prescribed fire, we've done work that has shown are much more at risk to impacts from southern pine beetle than those that have been managed with more open woodland type conditions. And so using that active management not only can restore some of these structures, but it can also increase resilience to some of these stressors associated with global change going forward. I think the stickier point, and the one that I think is a little bit challenging, and to be honest with you, a bit disconcerting in terms of where this proforestation discussion has gone, is that when we talk about any management, like cutting trees on public land, there's often this quick link to, well, they're doing it for profit, and they're doing it because industry is influencing them to do it. And what that often reflects is that we don't fully recognize just how much wood we use in this part of the country and how little of it we actually produce in our backyard. And there was a great publication put out in 2002 from Harvard Forest, and basically called The Illusion of Preservation, this idea of if you protect all of the land in your backyard, but still continue to consume wood, you're just exporting that demand elsewhere, right? Kind of that basic NIMBY principle. And if we look currently at the northeastern states, what we're looking at here is how much wood products they consumed in 2020 compared to how much was actually harvested in that state. Outside of Maine, which ironically is absorbing the demand from many of these other states for wood products, the rest of the Northeast is a major net exporter of their wood consumption needs to other parts of the globe, other parts of the region, other parts of the country. If I throw New Jersey up there, based on your most recent numbers, you actually harvested less wood than the state of Connecticut during the last measurement interval for FIA, but given your population size and basically the economic conditions of the state, consumed quite a bit of wood. And so when we talk about we want to no longer harvest any wood on a portion of our land base, but we don't stop consuming wood the exact same day, we are basically exporting that need to other parts of the country and other parts of the globe. And as we think about equity and environmental justice dynamics around our consumptive use, I have a hard time in this current environment thinking about kind of consciously doing that without acknowledging the global impacts. And to that point, ironically, what Bill Mumont proposed at the beginning is already what's happened in terms of the allocation of forest land globally. And Bill mentioned this again when he talked about what was happening in the Northwest as well. And there's an excellent paper that really looks at global forest allocation and global use called Plantations and Protected Areas. And really what it summarizes is that we've essentially divided the global forest estate into the places we protect, which are often very much linked to affluent portions of the world, like the Northeastern US, where we can afford to pay for wood products from elsewhere. And we've shifted that demand to other parts of the country, as well as other parts of the world that have less opportunity and certainly less ability to kind of fight the forces of conversion of native forests into plantation. And where we now sit globally is that we're already almost at that goal that Bill Mumont described, that 46% of our wood comes from plantations. And those of you that are from New Jersey, which is the majority of you, know there are not wide-scale plantations in New Jersey providing this wood. And so we are exporting that need to other parts of the globe. And so when we think about forest conservation, part of it should be thinking about how is my role as a consumer of wood products daily, whether it's Amazon packaging, the cellulose in your toothpaste, the wood you're buying, how is that impacting where that consumption is going and what other parts of the country and what other communities might be affected by that. The final piece, and Bill mentioned this already, is that with management, we recognize there are trade-offs when we only follow a single objective. And all of us know that are students of forest history, the Multiple Use Sustained Yield Act, was not a perfect act and really was in response to some of the kind of legacy of poor management that many of us still use as a caricature of current forestry. But what that was really designed to do is to push back on this notion that we just maximize volume production from forest land. And so we've known for a long time singly going after one objective is going to really have trade-offs with others. And so singly pursuing carbon, singly pursuing a single species we know there's going to be trade-offs, and that needs to be acknowledged when we come up with these plans for public lands. And so as an example, to some work that Caitlin Littlefield did that was recently published in Conservation Science and Practice that looked at some species that are dependent on disturbance for their habitat. And so chestnut-sided warbler pictured here, Barron's buck's moth pictured here, both species that are dependent on kind of open conditions, shrubby conditions that, yes, as Ed Faison said, will be found maybe in low abundance in disturbed areas in kind of mature forests, but really are kind of found at their highest abundance and breeding abundance in these habitats. And so if I were to create early successional forest or restore pitch pine scrub oak barrens, I'm certainly at the stand level increasing the habitat for these species that are declining, right? It's the other crisis we're dealing with besides climate. At the same time, I know that I'm reducing the carbon storage in these trees. It's just a trade-off that's going to happen in that system. At the landscape scale, by creating these less represented habitats, I'm increasing the diversity that's out there, right? And so having that diversity of conditions that we certainly can depend on natural disturbances to create, but historically things like beavers and Native American burning, processes we don't allow to occur at broad scales anymore, we're creating this at least, around 5 to 10% of the landscape, depending on where you are in the region. At the same time, especially thinking about the pine barrens ecosystems, we're reducing risk. Bill mentioned that, kind of distributing that risk across the landscape and enhancing kind of the diversity of responses that are out there for resilience. And so kind of bringing in those trade-offs is pretty critical.
2 minutes, Tony.
Perfect. So looking at kind of if this was a 200-acre area of forest, which it is, but within New Jersey, what you're looking at here is a LiDAR image. And so the kind of the colors here, this is just canopy height model. So the darker the color, actually the shorter the trees. So what you're looking at here is really some different intensities of ecological forestry happening, ranging from, again, that passive management. So no management's happening here. Here, single tree selections being used to kind of accelerate old forest conditions. Here, we're using a mix of kind of opening sizes and thinning, so what might have been called variable density thinning in Bill's presentation. And likewise here, similar idea. So obviously more harvesting, these are 1 acre openings is happening in these landscapes versus those. And I recognize, and I think many of us should recognize, that in these areas where they're not harvesting or doing lower impact forestry, it's going to have the highest levels of carbon storage. It's going to have the greatest abundance of interior species. But it's also, when we look at kind of the portfolio of functional traits in that forest from our work, it's shown the lowest level of future adaptation potential in terms of tree species diversity. In these other areas, we know they've cut trees. There's going to be lower levels of carbon storage, but we also have the greatest abundance of young forest species in those areas. And ironically, many of those interior forest species, fledglings, are using those open areas also for foraging and so forth. And then looking at the adaptation potential of these areas, much higher in terms of the portfolio of species that are now regenerating in these spots. And so I really think we need to stop looking at maximization of a single objective. I recognize and acknowledge the climate crisis that we're dealing with, but there are many other things that we value from forests. And so maximizing carbon, especially if we don't think about what that does in terms of trading off other values we get from those areas, including kind of the equity in wood production for New Jersey, the Northeast, the US, really is not a good long-term solution for both sustainable societies as well as sustainable forests. And so there's room for both. Again, I'm strongly a fan of having reserves and managed areas. But the key is that we're looking at this through the lens of diversity, complexity, and making sure that adaptation, again, what Bill Keene was talking about, we have these multiple objectives that include carbon are being satisfied across the landscape. We've moved so far in the profession to be back to thinking about one objective again. So I'll stop with that, and certainly I know there's lots of questions for others, so I can end there.
Yep. Thank you. All right, guys, we're about 11:15. So I would say, Eileen, Anjali, if we're good, we got about 15 minutes just to kind of give these guys a few more minutes of discussion. So we'll just go in the same order. Give yourself 2 to 3 minutes to kind of make any kind of clarifying points, ask any questions of each other, and just, we'll start a conversation. So Bill Mumma, you go ahead.
Okay. Well, I don't disagree with anything that either Bill or Tony said about what is possible, but I have to look at what is actually happening. Isn't it remarkable that Canada's managed forests have become a net source of carbon dioxide rather than a sink in the past decade? Clearly, they're not doing what you guys are suggesting. I've been working with people down in the Southeast United States, which is being just decimated to produce wood pellets for Europe. There is no thought being given to the way that you're talking about managing things. So the difference between the idealized and very real, I mean, I know there are real examples of it that you're talking about, and the reality of what's going on the ground is there's a large gap. U.S. Forest Service, their coal maps show that forests of western Massachusetts are 3 times the carbon density as those of Maine. And that's because of benign neglect over the last 100 or 150 years in Massachusetts, and the intense harvesting in Maine. I think we have to look at the, I mean, I would love it if everything that was managed for production was done the way you guys are talking about. But there's and the other point is, we come from a position of saying that 70% of our forests are timberlands, right? That's where we're starting. The presumption is they're to be harvested. And the fact that in fact, when we discussed this in Massachusetts, the forestry people, the New England Forestry Foundation, is opposed to even setting aside 1% of the state land, of the state parks, not to be harvested. They want it all. So there's an asymmetry here that's really troubling in reality. And so I strongly support what you guys are claiming can be done. But the real fact is it's not being done in practice in many places. So how do we get that to happen? And we don't have a lot of time. I agree with you. We can't just say a forest is much more than just carbon. But we have downplayed that. I mean, less than 7% of 48 state forests are more than 100 years old. Saying that wildlands can be 7%, I think that's not good enough. So let's talk about how can we get that balance better, using your knowledge for what can be managed, and these other values that need to be addressed.
Great. You know what, Ed, you can go now, or if Tony or Bill want to go, that's fine too. I don't care the order. So does somebody want to jump in?
If those guys want to respond, that's fine. I'm happy to have them do that. I don't, do you guys want to respond, or do you?
Yeah, I just might point out, Bill, that the southeastern forest you're talking about, I mean, that is really where so much of our wood's coming from. And so it's, again, we're kind of pushing that impact elsewhere. And again, I'm not advocating for like widespread management of New Jersey's forests or Massachusetts forests, but as a Massachusetts native that grew up consuming volumes upon volumes of magazines made out of the forests that are getting, hit hard in Maine, I had no clue, and I worked in Western Mass and in the 1/10 of 1% of old growth in that landscape. And that was a heavily impacted area that now has formal wildland reserves being planned for it. But I think even my privilege of being able to do that and just drive literally from central Massachusetts all the way to Western Mass and never see a cut tree is partly because I was able to afford kind of buying that from other places that are new. So I think I totally get it, but I think there's broader dimensions now in terms of just owning a little bit of our consumerism around forest products, and that, we put up this model of what plantations are terrible, but sadly, like some of the great holistic management that Bill's talked about and that we'd want to do, like I think there's a lot of appetite for that in the Northeast, but there's now a lot of barriers being put up to any harvesting in the region around proforestation. So I think we need to be careful about acknowledging that unless we can stop using wood tomorrow, we need to reduce our consumption and recycle and all those things. We're just pushing that elsewhere. And so where's the global balance, and even getting that wood to us? What's the carbon impact of a 2x4 coming from Oregon versus, so I think it's a global issue on many fronts. And so the local solution is important, but we need to think about the ripple effects from that. So I think we need to be careful about how much we emphasize plantations carrying the weight going forward versus maybe a more integrated approach over time.
And Ed, if it's okay, I'll respond too.
Sure.
So Bill, I appreciate your comment, but if we want to focus on realism, I think it's also really important to be realistic about the incredible variation among regions in terms of forestry practices. I mean, we all know that the Southeast has been the poster child of kind of native hardwood conversion to pine plantations for pulp and paper, and now increasingly wood chips. And that's a severe problem. We can also look at the reinvestment of capital by the timber industry in the Southern Hemisphere, which has been a major trend over the last 20 years, really shifting a lot of our wood production for pulp and paper, but also saw timber to places like Argentina and Uruguay and Chile, New Zealand, and New Zealand is like the classic example of where they implemented this dichotomy of like strict protection versus everything else in plantations. And so, yeah, that has been a trend in other parts of the world that we want to avoid here in the Northeast. You know, and parts of Canada, not all of Canada, but parts of Canada are the way you describe, particularly out west, British Columbia, places like that. And that's what we want to avoid. And thankfully, in New England and other parts of the Northeast, we do have the third leg of the triad that Tony mentioned, that middle ground of ecological forestry. And that's what we should be pushing, that in conjunction with reserves, rather than the idea, the sort of like, I'll be blunt, I think of it as a scare tactic when we say that everything that's not protected is going to be managed like Vancouver Island. I mean, that's absurd. And what we need to push the idea that there's that middle ground of ecological forestry in New England and the Northeast.
I'm certainly willing to push the middle ground, but there are a lot of places I don't see it. And so that's how do we deal with that? And here's the problem: when the public sees those kinds of things, it makes them really gun shy about forestry. And here's one other thing: you mentioned storing carbon in wood products. You know, because your papers say this, that there is more carbon dioxide released in harvesting than there is saved in the lumber that's produced. So we've got to do the math right and be honest about that.
I agree with you 100%. And that's one of the most complicated, tricky topics, as you know, actively debated in the literature. But, you know, as a scientist, I have to constantly stay open-minded to new research that's coming down the road. And when I published on that topic, we were talking about the life cycle of wood products as existed at that time. What people are talking about now is trying to shift towards more of these durable wood products and mass timber, where the sort of admissions to storage ratio is different. It's different. It's still not, in my opinion, as good as old growth forests. I still agree with you on that point, but I recognize that the extent that we're going to use timber, if we can increase somewhat the amount of carbon that's stored in our wood products, rather than having a throwaway society, that would result in a net benefit, which is why I believe in this portfolio approach of using, you know, sort of throwing everything that we can at climate change as a natural climate solution.
Hey, Ed, why don't you wrap us up? Take a couple minutes and you wrap things up for us.
Yeah, I mean, I think what I see as one of the common threads of the talks is that there's going to be room across the landscape for many different management and, you know, wood harvest activities, almost regardless of how much land you set aside as wildland. So there's a huge range of options of setting aside, you know, different percentages of wildland. So in New England, for example, there's 3% of the landscape as wildlands. Well, you know, as Bill said, that's not a great balance. And, you know, what if that number jumped up to 30 or 40%? Would that preclude all of the activities that Bill Keaton and Tony mentioned? You know, I would wager not. So again, I think, as they said, there's a whole lot of, you know, it's not this dichotomy. And I think that we would agree that there is a huge range of changing the percentages that would still allow for a lot of these activities to take place.
Got it. Okay.